All right, so now let's look at an example, one of the examples that are going to be helping us to understand the concept of change of momentum. So let's look at this example number 1 here. A tennis player serves a tennis ball towards his opponent. The ball moves through the air with the momentum of 11 kilogram meters per second east, and then the opponent hits the ball back in an opposite direction, and then the momentum of the ball changes to 8 kilogram meters per second to the west. So that is what we are given here. All right, so then the first question says calculate the change in momentum of the tennis ball. All right, so I want you to understand this. So remember, this is a tennis ball that is have a momentum of what? Of 11 kilogram meter per second. Then there is a tennis player here that is it's gonna be batting this ball back, right? So think about this tennis racket here. So it's gonna be boom there. Then that it hit the ball back. So the ball was bounced back from that racket to the west, then with the momentum of 8 kilogram meters per second. So that is what the scenario that we understand what happened on this case here. So now let's look at the first question. Says calculate the change of momentum. So then what is a change of momentum? Is delta P equal to P final then minus P initial. So remember, the tennis ball, we treating this is going to be our initial situation because it's before it's hit up with the racket of that tennis player. Then this is going to be our final momentum because this is where the incident happened. So remember, the issue of initial and after, it's based on the fact that of the incident where the event happened. So that is what it's based from. That's how you determine that base from, to say that's where there was a collision or a contact between these two. All right, so now then most important thing is a sign conversion. So in this case, I'm gonna treat this as negative, this as positive. So what that means? So it means this is gonna be positive, this is gonna be negative. So now let's calculate this. The final momentum, it's negative 8 minus the initial momentum is positive 11. So that means the change of momentum is going to be negative 19 kilogram meter per second. So therefore the change of momentum, it's 19 kilogram meter per second to the west. So that is what the answer is going to be. So that is that. All right, so now let's look at number 2. Then when you're looking at number 2, then we are looking at that one. An arrow is shown with an initial momentum of 20 kilogram meters towards a target. So let me erase this so that we can able to answer that. So when we are erasing this, let's look at that question number 2. How is we gonna attempt it? So if I'm looking at question number 2, an arrow is shot initially with an initial momentum of that. So in this case, they are telling us this is an initial momentum towards a target, that it penetrates the target and its momentum changed by 4 kilogram meters per second, then in an opposite direction. Calculate the final momentum. So let's understand the question. Sometimes the questions also give you the clue what you might be having in the statement, if in case you are not too sure. So in this case, we are 100% sure that 20 kilogram meters per second is an initial momentum. So sometimes we might be confused by this term where they use by. Then if you're looking at this one, it says the momentum of the bed changed to. So I think let's try to clarify that. So when I'm saying the momentum changes to, so that means it's a final momentum. But whenever I'm saying the momentum changes by 4, that is a change of momentum. So that's going to be very, very important to understand that wording there in our statement. So this is going to be the change of momentum, of which is going to be 4 kilogram meters per second. So now whenever we are answering this question, we're going to write the formula exactly the way it is: final minus P initial. So remember, the most important thing every time is that we must always stick to the sign conversion. So in this case, we don't know what the arrow was shot into, whether it was shot in this direction or whether it was shot in that direction. But what we know that the change of momentum was in an opposite direction. So that is what we know. So automatically, whatever sign I choose for this one, it means it must be not the same with the initial momentum, because this was opposite direction to that. So in this case, I'm going to choose this one to be -4. Then I'm looking for P final. Then this is going to be the +20, as you can see from here. Then what we're going to solve for P final is going to be +16. So there's going to be 16 kilogram meter per second. So in what direction? In the same direction where the arrow was shot. So in the same direction towards the target. So in this case, in the same direction was the initial momentum. So let me just say like that. So that was the case. So in this case, remember, I assume positive was going that direction. So therefore, it's going to be the same direction where the object was shot. Then let's look at this one. I extracted this question from the exam paper, one of the exam papers that were there. Then I want us to look at this one. So a tennis ball of a mass of 60 grams strike a wall perpendicular at the velocity of 12. Then it rebounds back with the velocity of 10. So what we when we understand this scenario, it's look like this. So again, they did not specify what direction the tennis ball was coming from. So we're gonna just make our own model just to understand. So the tennis ball, might be striking the wall from this. Then we know this was 12. All right, so grade 12, as we're looking the last part of the momentum and impulse, we are looking at the part number 3. So it's very linked to the concept that we are discussing, the change of momentum. So that is what it's going to be very, very important to understand that. So now, what is an impulse? So to understand the impulse, remember what we have talked about. We said that the momentum of an object, it's going to change whenever there is a force involved. So remember, that's what we said, that the momentum of an object, it can only change if there was a net force acting on an object. So that is what it's very, very important to understand. So why the momentum of an object is changing because there is a net force acting on an object. So that is what it's very, very important. All right. So now we are saying whenever an object collides, let's say this is an object here, it's colliding to one another, or it can collide with the wall here. it's going to be colliding with the wall here. We are saying during that collision moment, so here, the ball and the wall is going to be in contact to one another. Remember, a force is a push or pull. A force cannot act on an object without touching it. So a force is acting on that object during this moment here. So in that moment, there is a time taken for the force to act on this object. So remember here, I'm having two objects. I'm having a tennis ball. I'm just using the previous example here. So this is a tennis ball. So it's hit up on the wall. So there is a force between a tennis ball and the wall. And that force is going to be acting for the particular time. Remember, once the two objects are no longer in contact, the force is no longer acting, but it's only acting when there is in contact. That is very, very important to understand from what Newtons have discussed in Newton's laws. So we're saying a force is it's only acting on that object whenever they're in contact. So it means it's that moment where they become in contact, because after contact the force is no longer there, but the object keep on moving because of their momentum. So I hope that makes sense. Why this object it's moving in that direction? It's not because there's something pushing it. It's not because there's someone pulling it, but it's moving because of its momentum. So why this tennis ball it's bouncing back? Why it's keep on moving in that direction? Because this is because of its momentum. But the biggest question here is that why this tennis ball is not continuing going in that direction? So it's because now there is a force acting on the tennis ball in that direction. So that's going to be very, very important then to understand that. So now when you're looking at the impulse, we are saying the impulse is the product of a resultant force acting on an object and the time taken for that force to act on an object. So that is what we say the impulse is. So we are saying the impulse is the time taken for a net force to act on an object. But remember one most important thing. When a net force acting on an object, it's going to do what? It's going to change the momentum. So that's the reason why we are also going to say that what is an impulse? Impulse is a change of momentum of an object. It's equal to a change of momentum of an object. Why? Because the change of momentum is only happening only if there is a net force acting on that object. But we know that a net force is acting on an object for a particular time. That is the reason why we want to just measure that impact, so of that force acting on that object. That is what is going to be very, very important. So therefore now we combine these two formula, because if this is equal to the impulse and this is equal to the impulse, so therefore it means we can also make a nice impulse theorem equal to a change of momentum. So that is what this is another formula that we're going to use in most cases to solve most of the problem. But I want you to understand this. What is an impulse? Impulse is a net force times, is a product of a net force times the time taken for the force to act on an object. Or impulse is a change of momentum of an object. So remember that. So now when we combine these two, it's going to give us this nice formula here, of which we call this formula, it's an impulse momentum theorem. So that is what we are saying, because it's also linking the force and the change of momentum. So that's why we say it's an impulse momentum theorem formula that we use in to understand more collision, more effect, or the impact of the collision. So in this one, it helps us to understand the impact of the collision. So it's also helping us to understand how can we safeguard ourselves during those collisions, because the collision, they can be very, very dangerous to our life. So now once we understand this theorem, then it helps us to understand that how can we put safety measures that can help us to survive during the collision. So what do we see from here? Then we see that so another important thing here is that like momentum, impulse is a vector quantity, obviously, because it's a change of momentum. Then momentum is a vector quantity. This is also a vector quantity. The direction of the impulse is the same direction as a net force that is causing it. So that is going to be very, very important to understand that. So what is the SI unit? Obviously is newtons times second, or then it's kilogram meter per second. So it's going to be the same SI unit as the momentum, or it's newtons per times second. So that is what the impulse is. All right. So now let's look at the example so that we understand the impulse and also the impulse momentum theorem. So let's look at this example here. So on this example here, we got a 30-gram soccer ball. It's kicked against the goal post. Then it's hit the post with a velocity of 15 meters per second. Then it's bounced off from the post after 0.2 seconds with a velocity of 10 meters per second. So now when you're looking at that, let's say this is gonna be our post, our post here. Then this is a soccer ball. So the ball was kicked against this one. So the velocity that was kicked is 15 meters per second. But then the ball, when it's hitting the post, the ball it took about 0.2 seconds in contact with the post. So then after that is bounced back with the speed of 10 meters per second. So that is what we know there. That's what's happened there. So now the question is going to be calculate the impulse. Calculate the impulse that the post exert on the ball. I want you to understand that. Calculate the impulse. So what is impulse? Impulse, and remember we said impulse is equal to a net force times the time taken for the force to act, or impulse is equal to the change of momentum. Obviously in this case it's going to be the momentum of the ball. So now when we want to calculate this, let's think about it. Which one between these two that's got more information that we need? So remember, I can simplify this as VF minus VI. So between the two, which one has got more information that we can able to solve or we can use? We don't know the net force, so we can't use this formula here, even though we know the time, but we don't know the net force that the post exert on the ball. So because there is a force the post exert on the ball, but we don't know what that the amount or the size of the net force, but we know the mass of the ball. We know the final velocity of the ball. We know the initial velocity of the ball. So it means now to answer that, we're going to say the impulse is going to be equal to the change of momentum of the soccer ball, like that. Then remember the direction here. So in this case, I'm gonna stick to this. I'm gonna use this direction as negative. I'm gonna use this direction as positive. So in this case, I'm just changing my sign direction here. So when you're looking at this one, the mass of the soccer ball is 300 grams. Then must be converted to kilogram divided by 1000. This is going to be 0.3. Final velocity is going to be positive 10 because it's going in that direction. So it's going to be positive 10. So here I got a minus, but remember I choose this direction as negative, so this is going to be negative 15. So I'm putting negative 15 here, then I'm putting my bracket back. This is going to be 0.3 times what? 10 minus 15, that's going to be 25. So that's going to be 25, positive 25. Then when I do the calculation of this one, it's going to give me what? 7.5. So then this one is going to be 7.5. Then the SI unit of the impulse, remember the SI unit of the impulse, it's either is newtons per times second or it's kilogram. Okay, let me not put "or" because some of you're just gonna think this is a one thing. So it's newtons per that. So now you notice that the impulse is positive here. So what that means? It means that the impulse is in that direction, because remember we said that the positive direction is going to the left. So it means the impact was going to the left. So it means the ball experienced a net force that goes to the left. That's what it means by that direction there. So when you're looking at number B says calculate the average net force acting on the ball during that collision. So now we're going to apply the impulse momentum theorem. F net times delta t, we can apply that is a change of momentum, or we can also use this simple form. Remember, these are the same thing, so it's depending on you which one do you figure it first. So either way that you found it easy for you, that's going to be very, very important. So now then, what is the net force? We don't know the net force here. Then what is the time? The time was 0.2. The change of momentum, remember this is a change of momentum, that's going to be 7.5. So this is going to be 7.5. So it means here I'm just going to divide by 0.2, divide by 0.2. So it means the net force is going to be 7.5 divided by 2. That's going to be 37.5. So it means it's going to be 37.5 newtons. Remember now it's positive. So what it means by positive, it means in that direction. Remember we said this is a west direction where it's positive according to my assumptions of the motion. So that is going to be very, very important to understand that. Alright, so that is how I can solve the problem that involving impulse and momentum. Alright, so now I just want us to look at the application of the impulse momentum theorem. So I want us to look at the application of this theorem here. Application of impulse. So what is an application of this? So how can we use this in our real life situation? So remember we said that the net force times the time taken during in contact, then it's equal to a change of momentum of an object. So when we understand this relationship, first thing first that we notice that we can rewrite this like that. So we can rewrite this like that. Net force is equal to a rate, or net force is a rate of change of momentum. So that's what it means. So remember, whenever we looking at the time, so time it's how fast it is, it's a rate. So this is another definition of a net force. So we are saying here net force is a rate of change of momentum. So what that means, we know that the higher the net force, what we see from here is that when the change of momentum, it's higher, it's also increasing the net force. Remember now, it means more force acting on that. So think about two cars that are becoming into collision like that. So think about this. These are the two cars that are coming into collision there on the road. So this one is coming, this one is coming. So that is going to be very, very important. So obviously this might be moving at a very high speed. This is moving at a very high speed. So whenever these two they collide, we are expecting that it's going to be a serious injuries that are going to be caused by these two car crashes in that scenario. So that is what we know that's going to happen if the two cars are coming at the higher speed, because the higher the momentum, the higher the net force. So it means the higher the force is going to exert on this one, the higher the force is going to exert on that one. So that is what we know. So remember, by Newton's third law, there is a force this is going to exert on car 1, then there is a force car 1 exert on car 2. That force will be the same in magnitude but in opposite direction. So that is what Newton's third law argues about. Okay, so now our argument is this one, is that when these two cars are coming into collision, they're going to be a high net force acting on one another, because they will be having a very, very highest momentum. They're going to be very heavy. They're going to be having a high speed. So it means their momentum is going to be very, very high. So that is what we know. The momentum is going to be very, very high. So therefore now, how can we decrease the impact? So remember, the force is all about the impact. So now how can we decrease the impact? So it means we can only decrease the impact by trying to increase the time of contact. So remember, these two, whenever they collide, they must take some time when the force is acting on them. So in other words, then when we increase the time of contact where the force is acting, then it's going to have a lower impact compared to when someone it's having a minimum time in contact with that surface. So we see this thing they're using this. We see this theorem, they are using it even on a lot of sport games. For example, think about on the jumping. Think about if someone can land on a concrete. So this is a concrete, so that we understand this concept. Think about, this is a concrete and this is a sand. So between the two, which one between the two scenario? So this is a sand. So between the two scenario, which one is gonna cause more damage on an object when it's falling on these two surface? So now you got this object that is being dropped on this surface. You got the same object at the same height is being dropped at this surface. Between the two surface, which one do you think is gonna have more impact? Which one's gonna be having more impact on this object? So when you're looking at the concrete is very hard. So it means whenever this object become in contact here, it's becoming contact very quick. It's like going to bounce very quickly. But a sand, what the sand does, it delays. So the sand, it delays. So as it delays, so it means it's decreasing the net force that is acting on that object. So that is what this principle talks about. It talks about the fact that if we can increase the time of contact, we decrease the impact on an object. So then therefore now the application of this is coming from the fact that if we increase the time of contact, subsequently we are decreasing the net force. We are decreasing the net force. We are decreasing a net force on an object. Therefore low impact. So therefore low impact on an object. So therefore low impact there. So that is why we are using this principle then we use this principle in our daily life practices. By understanding this principle, it helps us to enjoy our life and enjoy a lot of sport. Think about whenever they're doing those junkie jumping, they put in what? A lot of sponges. Why? Because the sponge, it's gonna delays the object. So by delaying the object, it's increasing the time of contact with an object. So when you fall on a sponge, you take more time until you bounce back. So the bouncing time is becoming more. So by doing that, it's decreasing the impact or the net force that's going to be acting on that object. So that's how they apply the impulse. That is why it's very, very important to understand this principle in a real life situation. All right, so there are many applications that we are using in our daily life where we are involving or we are solving a lot of problem by using this concept. So in most cases, in a collision, for example, then what we normally see that in these cars there is also a seat belt that was in use in the car. Why the seat belt is important? Because whenever you are in a car, then the car is colliding. So what's going to happen? Remember, this is you are sitting there on the seat. So if I'm sitting on this seat here, the seat belt, the function of it is to ensure that it delays me before I can hit up the steering wheel, the steering here, or the windscreen. So it's helped me to do that. And also most of the car, they got something we call it's an airbags. So airbags, it's more of like they got an air in that sponge. Whenever the car crashes, they become the bubbles like that. It's like an air bubbles. So whenever then now, remember, you'll be moving with the same speed as the car moves. If the car was moving with 180 km/h, then you are also moving with that speed. So therefore now whenever the car crashes, then the airbags comes out quickly, so that whenever you hitting this, they delay you before you hit that strong object, or that steering wheel, or you getting out in the window, then so that you're going to be getting more injuries. So it's preventing the injuries by doing what? By lowering the impact. So the whole aim is that it lowers the impact by doing what? By delaying the net force. By the time the net force is acting, so it's taking more time for the force to act on an object, so they lower the impact on an object. So I think that is the whole summary of how that can be applied in our real life situation.